This video will help you to learn how to solve multiple linear regression problem. And in this video, I am going to solve multiple linear regression using least square method, which is a direct method. And in this lecture, I am going to solve the equation of x1 on x2 and x3. So this is the best method among other methods to solve multiple linear regression. So let us see what is multiple linear regression basically. Obviously, this is an extension of linear regression. In linear regression, we consider one dependent variable and one independent variable. And in the case of multiple linear regression, we consider more than 2, 3, 4, 5 independent variable, whereas one dependent variable. So it is generally explained the relation between multiple independent. Very importantly, multiple linear regression means here we entertain multiple independent variable. It may be 4, 5, something like that. That multiple independent variable is also called a predictor variable, and here we will consider only one dependent variable, which is also a criterion variable. So we will study the relation between multiple independent variable over one dependent variable. Yeah, that dependent variable is modeled in such a way that it functions several independent variable with corresponding coefficients along with constant term also. So as I told you, it is a study of more than two variables. That is why we are dealing it here in the multiple linear regression. So here one variable is dependent variable, that is x1, and other variables are x2, x3 are independent variable. And we use linear regression, multiple linear regression to predict the future. So it is used as a predictor. So what do we predict in the case of multiple linear regression? Here we try to predict the change in the dependent variable according to change in the independent variable. Say for example, we have two independent variable. Whatever the changes occur to these two independent variable, we also see the relation, the affection, the impact on the changes of independent variable over dependent variable. So this is very important since it is quite complex in nature. Using this equation method, we will make it very easy. So let us go further then. So we have two methods for solving multiple linear regression. One is least square method, and that is direct method. One more is least square method, which is a shortcut method. Here we use some formula to solve multiple linear regression. Here we use equation to solve multiple linear regression. This least square method, direct method, is a very best method. Very best method in the sense the less confusion. We will go in a sequence. But here you need to remember the formula, and I will let you know how to formulate that formula too. So let us go for that least square method, which is direct method. As I told you, here we use to solve the multiple linear regression using equation. As such, we do have two equations. Firstly, basic equation and normal equation. So basic equation is this. In the case of basic equation for x1 on x2 and x3, here x1 is dependent variable and x2 and x3 are independent variable. We see the changes in independent variable over dependent variable. So this is a basic equation of x1 on x2 and x3. So here the basic equation is x1 is equal to a 1.23 plus b 12.3 x2 plus b 13.2 x3. I will explain this, what is a, b, b12.3 and b13.2 in further slides. Basically, this is the basic equation of multiple regression equation on x1, on x2 and x3. So we have another equation also. When we see x2 as independent variable, then we have to see x1 and x2, x3 as independent variable. Then our equation would be different for x2 on x1 and x3. So then our basic equation would be x2 is equal to a 2.13 plus b 2 1.3 x1 plus b 2 3.1 x3. So this is a basic equation on x2, on x1 and x3. So we have already finished two combination. That is, since we are having 1 2 3 three variables under study here, so we saw that firstly x1 on x2 and x3, and now we saw x2 on x3 and x1. Now only one option we are left with, that x3 on x2 and x1. So that let us see the basic equation of x3 on x1 and x2. So this is a basic equation of x3 on x1 and x2. Here x3 is equal to a 3.12 plus b 31.2 x1 plus 32.1 x2. So basically we use this formula. So we also have normal equation for each and every basic equation of x1 and x1 on x2 x3, x2 on x1 x3, and x3 on x1 x2 also. So as I told, we shall see the extension of this basic equation. As I told you, that is normal equation. So in the normal equation we have three equation. In each and every normal equation, whether it is x1 on x2 x3, whether it is x2 on x2 on x1 x3, whether it is x3 on x2 x3, sorry, x1 x3, in either the equation we have three normal equations. So here, as I told you, we have basic equation. In the normal equation, first equation is a basic equation only. So just we have added summation. So example here, sum x1, here we have added summation x1. Here a here we will add n number of observation, and here b 12.3 it will be taken as sum x2 as summation x2, and here summation x3. So otherwise basic equation and in normal equation, first equation is same. This is a first equation. So here how I have taken, firstly in the case in here I need to consider only summation of x1 x2 x3 in case of first equation. No other things I will consider here. No other things may, in the case x1 square, x1 and x3, that I am not going to consider those things. Here only I am considering x1 x2 x3. So summation x1 x2 x3. So that is first equation. And second equation, second and third equation is this. So second equation how I have formulated here is, firstly we have to consider what are the possible combination of x1. So since we are dealing with x1 x2 x3, so I can have x1 one case, and x1 and x2 another case I can have, and x2 x1 and x3. These are the three combination only I can have with x1 on x2 x3. So first equation is based on this x1, second equation must be based on this x1 and x2. So here I have to take summation x1 x2, so is equal to a 1.23 summation x2. Now what we have to do is, we have to consider all the combination relating to x1 and x2 in the case of second equation. So for example, firstly here I have taken summation x1 and x2, and summation x2 which is relating to this x2, and here summation x2 square which is relating to this x2 only, and here summation x2 and x3. So here again summation x2 relating to this. So which means all other possible combination relating to x2 I have to consider in case of second equation. And except that this a 1.23 and b 12.3 and b 13.2 are same for all three equation. Let us consider a third equation, that is summation x1 and x3. Here also I need to consider all other combination relating to x3. Very importantly, you need to keep in your mind, you need to consider all other combination relating to x3. Say for example here summation x3, here summation x2 x3, here summation x3 square. So this is very logical in such a way which is formulated, which is modeled just like multiple correlation and partial correlation. So let us see what are these meaning then. So here, as I told you, x1 is a dependent variable and x2 and x3 are independent variable, and we know that b12.3 and b13.2 are partial regression coefficient which can be used solving these three equations. So this is the case of x1 on x2 x3. We have other two combination, other two basic equation also. For each basic equation we have normal equation also. Those things also modeled in such a way I have explained in the case of x1 on x2 x3. So let us consider x2 on x1 x3, which basic equation of this is this. So x2 is equal to a 2.13. So there we had 1.23. So here I have to consider 2 because we are dealing with we are considering dependent variable as 2. So 2.13, and so here 2 is a dependent variable, 13 is a independent variable. Here 2 is a dependent variable, 1 is a independent variable. In case of partial regression coefficient, we will see one dependent variable and one independent variable, keeping one more independent variable out of the ambit. So that is why b21.3. In case of multiple regression, we study two independent variable, the impact of two independent variable to one dependent variable. So here we have to consider that here 2, here I will consider other combination with 2. 2 is a dependent variable, as I told you. 3 is a independent variable. In here I had considered first independent variable with dependent variable second. Here I need to consider, I need to keep first independent variable out of the purview, and I need to consider third independent variable. So which is formulated in such a way which will be repeated in normal equation also. So normal equation for this x2 on x1 and x3 is this. So as I told you, first equation same, which will be repeated for normal equation, sorry, basic equation. So here x2 have considered summation x2, n is common, just we have taken in the last x1 on x2 x3, and x2 here x1, here summation x1, and x3 summation x3. As I told you in the first equation, we will consider all the combination of three variables. Firstly we have taken basic as 2 dependent variable 2. Now we are left over with first independent variable and third independent variable. That available options I have considered here. Otherwise these partial regression coefficient and multiple regression coefficient will be same thing as we formulated in case of basic equation. And as I told you, we will have also three combination in case of summation x2 x1 x3. One is summation x1, one more is other relation we established with x2 is summation x1 and x2, and one more is x2 and x3. Here you can see, here there is x2, here also there is x2, here also there is x2. So we will formulate only three equation for this. So for second equation I will consider this summation x1 x2. So here I need to consider all the combination relating to x1 because we will exclude x2 here. X1 relation which is established, first one is summation x1, second one is summation x1 square, third one is summation x1 x3. So here x1 is there. You may be confused, why should we take this summation x1, summation x2, summation x3, summation x1 x3, x2 x3. When we solve raw data, we have to obtain x1, x2, x3, x1 square, x2 square, x3 square, summation x1 x2, x1 x3, x2 x3. That we will know when we solve that raw data. So the same thing in the case of third equation, that is summation x2 x3. Here we need to consider all other combination relating to x3. So here summation x3 and summation x1 x3 and summation x3 square. So as I told you, here we have considered dependent variable as x2 and x1 and x3 are independent variable, and b 21.3 and 23.1 are partial regression coefficient. So let us see for last combination then. That is, last combination is summation x3 x1 x2. So the basic equation of this is same. So here we have considered dependent variable as x3, so we will consider other two variable into consideration, that is x1 and x3. So here I have considered multiple regression coefficient independent variable, and others two are independent variable. So 3 is a dependent variable, 1 2 are independent variable. Here b31, here in the case of partial regression equation, I have considered first one independent variable and one dependent variable, keeping one more independent variable out of the ambit of the study. So here in case of, here we consider 3 1, here we will consider one more independent variable 2. So 2 is an independent variable, 3 is a dependent variable. I will exclude one independent variable out of the ambit of the study. So we have also normal equation, 3 normal equation here too. So as I explained earlier equation, this will also form summation x3. We will consider another two option relating to other variables, that is x1 x2. So which is same like first basic equation. Yeah, as I told you, other relation which is established with x3 is summation x1 x3 summation x2 x3. Here I need to consider all the other combination relating to x1, that is summation x1 summation x1 square summation x1 x2, and here I need to consider all other relation established with x2 because which is combined with x3. So summation x2 summation x1 x2 and summation x2 square. So this is how we will consider formula in case of equation method solved by least square method, which is a direct method and which is the less confusion in nature compared to other method which we solve to in case of multiple regression equation. So now let us consider a problem, so that using equation x1 and x2 x3 we will solve this problem under multiple regression. So here we have three variables x1 x2 x3. In case of x1 and x2 x3, x1 will be dependent variable and other two variables x2 x3 will be independent variable. We have raw data relating to each variable. We will calculate further necessary things. Necessary things means we will calculate summation x1, we will calculate summation x2, summation x3, and thereafter we will calculate x1 square, x2 square, x3 square. Thereafter x1 on x2, x1 on x3 and x2 on x3. These things we will calculate. We will take a summation, sum of all these things. Thereafter we will go for solving equation. So firstly, regression equation of x1 and x2 x3, so which is given by basic equation that I have explained. So here I told you, here we have some of the values here, that is a 1.23, b 12.3, b 13.2. how do we unless you derive value of these three values, that is b13.2, b12.3, a1.23, you cannot solve the equation x1 on x2 x3. So for that, what you want to do is the value of constant is a 1.23 is a constant, b 12.3 and 13.2 are obtained by solving this normal equation we relating to this basic equation. So if you want the values of a1.23, b12.3 and b13.2, you need to solve this basic equation. So I have explained this basic equation. So we have three basic equation here. Okay, so now Firstly, we have to calculate raw data. Here what are the things we need to calculate, I will explain here. So solution on a summation equation for x1 on x2 x3. Let us consider raw data also, raw data given which is given in the problem. So using this, what are all the things we need to calculate? Firstly, summation x1 we need, summation x2, summation x3, summation x2 x3, summation x2 square, summation x2 which is I told you here, summation x1 x2, here summation x1 x3, summation x3, yeah, summation x2 x3, summation x3 square. Okay, firstly we need to obtain all these value, thereafter we can replace all the respected values to the equation. So here I have directly calculated those value. I cannot calculate the one by one in this lecture because it gets a lot of time. So I will explain you how I have calculated here. So here I have inserted x variable 1, and here variable 2, here variable 3. I told you x1 is a dependent variable in case of here, and here I have taken summation of it, total of it. So that is summation x1 will be 126. The same thing I have taken total here, summation x2 is 72. Here same thing I have did here, summation x3 is 56. So the summation x1 x3 x2 we obtained. Now we need summation x1 square, x2 square, x3 square. So this will be multiplied, all the values will be multiplied, that we got a squared value of summation x1, sorry x1 value. So 20 into 20 400, 30 into 30 900, 40 into 40 1600, 36 into 36 1296. So summation x1 square will be 4196. So same thing will be applicable to summation x2 square, that is x2 variable 2 values will be squared. So 10 into 10, 16 into 16, 20 into 20, 26 into 26. So here we are having that value, so that summation x2 square is 1432. Same thing will applicable in case of x3. So that is summation x3 value is this, yeah, 8 into 8, 10 into 10, 16 into 16, 22 into 22. So here we are having those values, summation x3 square, and now we have to multiply first variable with second dependent variable, sorry, first dependent variable with second independent variable. Yeah, that value is here. So 20 into 100 as a 10, 200, 30 into 16 480, 40 into 20 800, and 36 into 26 936. Now we have to consider variable 1 to variable 3, which means dependent variable 1 to independent variable 3. So 20 into 8 160, and 30 into 10 300, 40 into 16 640, 36 into 22 792. So finally we will take other two independent variable, so x2 x3. So 10 into 8 80, 16 into 10 160, 20 into 16 320, 26 into 22 572. So summation x2 x3 is 1132. So by this way we obtained all the required elements to replace to this normal equation. So next step is to replace the values we obtained in this calculation. So that is replacing the values to the normal equation. So we know that normal equation, we have three normal equation here. So firstly I will replace the value, the summation value I have pasted here, summated value. So yeah, here first equation is replaced here. Let me show you. So here summation x1 is 126, which is replaced here, and n is number of observation 4 in the problem. So here you can see n is number of observation, and each and x1 variable has 4 observation, x2 also 4, x3 has also 4 observation. So we do have 4 observation. So n will be, as I told you, 4. So n is 4. When I replace it that into that, n is 4, and summation x2 is this 72 b12.3, summation x3 is this 56, so 56b 13.2. so let us replace second equation to the values we obtained. Second, summation x1 x2, here we have summation x1 x2 2416. Here summation x2, so I told you 72 a 1.23, and here summation x2 square, here we do have summation x2 square, that 1432, and summation x2 x3, we have here summation x2 x3 1132. so we are just replacing the value to the equation. So let us replace the value to the third equation first. So third equation is summation x1 x3, here summation x1 x3 is 1892, and summation x3, here 56, here replace it with 56, and summation x2 x3 here is 1132, and summation x3 square, here 904, x3 square here 904. we have just replaced value to the variables, whereas these things, that is partial regression coefficient, are same, which will be obtained by calculating, by reducing, by making single value. Okay, let me show you. So firstly, let us consider first and second equation, then derive 4 equation. Thereafter I will consider second and third equation, and then I will derive 5th equation. Thereafter I will consider newly derived equation, that is 4th and 5th equation. When I simplify equation number 4 and 5, I will find any one of the value of b13.2, b12.3 or a1.23. so using that value I will find remaining 2 value which is available in this equation. This is what we will do in this equation. Then let us firstly consider equation number 1 and 2. So we have to derive at equation 4 by solving equation 1 and 2. This is equation 1 and 2, which is replaced into the equation by the original value of that. So here what is the logic? Here we need to cancel one value. For that we need to multiply first equation by 72. You may have confusion, where is 72? Here this is 72. 72 is this, and the second equation by 4. Here second equation value is 4. Second equation will be multiplied by 4. First equation will be multiplied by 72. Why we are doing this means, when we multiply 72 into 4, we will get some value, and when we multiply 4 into 72, the same value we will get. So thereafter we will cancel it. We can cancel one value and we can deal with other 2 value. That is the logic here. So when I told you multiply equation 1 by 72, so 2 by 4. So here I have multiplied that first equation. Here 126 into 72 is 9072. 4 into 72 will be 288, and 72 into 72 will be 5184, and 72 into 56 will be 4032, which means we have to multiply all the values available in the equation 1 from 72. Now we have to multiply all the values available in the equation 2 by 4. That is the logic here. So I have multiplied second value also. Second equation, 4 into 2416 will be 9664. 4 into 72, 288. 4 into 1432, 5728. 4 into 1132, So for 4528. So we have multiplied equation 1 by equation 2 value, equation 2 by equation 1 value. In that too we have to specify this value. We are not going to multiply with other value, we will multiply with this value only. So now we have to simplify this. To simplify this, we have to change sign first, very importantly. We have to change sign. How to change sign? Here there is a plus value, we will make it minus. Here also plus value, minus. So plus value will be minus, minus value will be plus. We will just change the sign. So when I changed that sign, so here look at here, plus value is here and I have made it a minus. Here also plus, I made it minus. Here also plus, made it minus. Here also plus, I have made it minus. So now I will subtract 9072 by 9664, 288 by 288. So 5184, 5728, 4032, 4528. So for here firstly I will obtain value directly 288 is will be cancelled from the equation. So remaining thing I will show you here, the derived value. So 9072 minus 9660, minus value is highest, minus 592. Here 288 cancelled, so 0. 5184 minus 5728 will be minus 544 because minus value is highest. So 4032 minus 4528 is also minus value, minus 496. So by this way we obtained equation number 4. What we obtained here, this is equation number 4. So now let us consider equation 2 and 3, because we have not considered equation 3. Here we have considered only equation 1, equation 2 to derive equation 4. Now let us consider equation 2 and 3. So equation 2 and 3. So let us have values of equation 2 and 3. Thereafter again we do the same thing. What we did in the last equation, we are also going to do the same thing. So which means multiply equation 2, this is equation 2 by 56. 56 is this equation 3 value, and equation 3 by 72. So equation 3 is this, which must be divided multiplied by 72. So this value by this equation, this value by this equation. So when I done like that, I got the same value as I obtained in the last equation. So that is 56 into 2460, 1,35,296. 56 into 72, 4032. 56 into 1432, 80,182. 56 into 1132 will be 63,392. So now 72 by this equation, 72 into 1892, 1,36,224. 72 into 56, 4,032. 72 into 1132, 81,504. 72 into 904, 65,088. So this is the same thing as we did in the last equation. Now again I will change the sign, and thereafter I will make a necessary change. So I will change the sign, so where minus will be plus, plus will be minus. So here all the values are in plus, so we have changed value into minus. So when we done like that, we will subtract now from first equation to second equation, so that we will derive fifth equation. So 1,35,296 by 1,36,224, minus value is highest, minus 928. So this equation will be cancelled, so will 0. 80,182 minus 81,504, minus 1,312, and 63,392 minus 65,088, minus 1,696. So this is equation number 5. So now we will consider newly derived equation. So because in the newly derived equation we have considered one value, so we have only three values here. So newly derived equation is this 4 and 5. By having 1 and 2 we derived at 4, by having 2 and 3 we derived at 5. Here also we will do the same thing. Equation, multiply equation 4 by minus 1312, this is minus 1312. Equation 5 by minus 544, here minus 544. So when we multiplied that, we got this value. So what, minus 1312 into minus 592, 7,76,704, and minus 1312 into minus 1544, 7,13,728, and minus 1312 into minus 496, 6,50,752. So now minus 544 by minus 928, 1,36,224, 500 minus 544 into minus 1312, so 7,13,728 minus 544 into minus 1686 will be 9,22,624. So again I will do the same thing. I will change the sign here. So all are positive sign, so I will make it negative sign. So and I will subtract one to another, so that I can cancel it one more value here. So 7,76,704. Yeah, here is a small correction. Minus 544 into minus 928 will be 5,04,832. So that is 5,04,832. It is not 1,36,000. So for 7,76,704 minus 5,04,832 will be that positive value, because here positive value is highest, so that is so 2,71,872. here this value to this value will be cancelled, and here 6,50,752 minus 9,22,624. here we will get minus 2,72,872. so now I can derive the value of B13.2, because we are having two values only. So I can easily derive this. So B13.2 is equal to 2,71,872 by this value minus 271,872. So we will divide that value one to another. So we got B13.2 in is equal to minus 1. So in the normal equation we had three values, that is A 1.23, B 12.3, B 13.2. out of these three values we derived at one value. So after deriving one value we can put that into equation and we can derive one more value. So then let us put B13.2 is equal to minus 1, the value into the equation number 4, so that we can derive on equation another value, because in equation number 4 and 5 we have three values only. We have cancelled one value in each equation 4 and 5. That is why we are not considering equation 1, 2, 3. Okay, so we will place that value. So firstly, this is a equation number 4. So let us since we are having B13.2 value, I can replace it here and I can find some value. So when I replace it that here, this value 13.2 is minus 2, minus 1 here. So now we have to multiply for further simplification. So here 496 into minus 1. So now we got a minus 496. So minus into minus, it will be plus. So for further step, minus 592 is equal to minus 544. B12.3 plus 496. Let us derive next simplification. So 592 is taken into equals. Now it has changed its sign. So 496 plus 592. So we got that value minus 544 B12.3 is equal to the we are added this value. These two values added, that is 1882. So now I can take a B12.3 outside. I can divide two value so that I can obtain one more value. So we are having one more value here. So one more value is 1088 by minus 544. So we got one more value, that is B12.3. So 12.3 is minus 2. So by this way we obtain two values. Now we have to obtain one more value. So one more value is this, that is A1.23. For that I will consider equation number 1. So I will since we are having two values, that is B12.3 and B13.2, I will replace these two value and I will derive this A1.23 value. So let us replace all the values to the original value calculated from the problem. So summation x1 is 126, n is 4, a 1.23 we do not know this value. So b summation x2 is 72, b12.3 just be derived here, b12.3 is minus 2, and summation x3 is 56, b13.2 we derived in the last step, that is minus 1. So we will simplify this for further. So that is for my 72 into minus 2, which is minus 144, 56 into minus 1, which is minus 556. Now I will add minus value. So for minus 144 minus 56 minus into minus 200. So now I can go for next further simplification. I will take 4a 1.23 outside. Now 126 when I take 126 within the equals, the value is changed to minus, so minus into minus plus. So 126 plus 200, so which is 326. Now I can find the value of a, so that is a 1.23 divided by will be 326 by 4. So finally a value is this, a value 81.5. So we have found all the three values available in the basic equation, that is b13.2, b12.3 and a1.23. So this is the this is the desired equation. So if you want to check whether it is a desired equation, we have to verify the result we obtained in using the equation. Let us verify the result then. So if it is verified, then this is a desired equation. So we have obtained three values. One is a b12.2 is minus 2, a1.23 is 81.5, b13.2 is minus 1. So then let us replace these three values to the normal equation 1. So normal equation is this. I will just replace the normal equation by their respected value. So summation x1 is 126, n is 4, and we got a 1.23 value is this 81.5, and summation x2 is 72. So ignore this b here, and b12.3 is here minus 2, and summation x3 is 56, b13.2 value is minus 1. So now we will simplify this value since we have taken all the values. So we'll simplify. 72 into minus 1, 144, 56 into minus 1, 56. So 4 into 81.5 will be 326. Now again I will further simplify this. So minus into minus, minus 200, 144 minus 56, 200. So now we will simplify this again. So 326 minus 200 is 126, which is exactly equal to this summation of x1. So this is tally, this is verified, and the value obtained in this these three values are perfectly right. So by this way we obtained we calculated multiple linear regression using least square method, in that to equation direct method. So thank you so much for watching this video. Please do subscribe to my Vision Academy YouTube channel.